Hello everyone, welcome to this new webinar on borehole extensometers, comprehensive solution for axial monitoring. So thank you for joining us today. It's the third webinar of Sisgeo. After the inclinometers and the piezometers, now we are dealing with extensometers. The first extensometer I ever installed was 20 years ago. I can explain exactly what I did, but it's not the subject here. But just to tell you, it's a matter of experience. So the right choice of the extensometer and then the right way to install it. My name is Julien Prouvot. I'm a geotechnical engineer based in Nancy, France. I started my career in 2004, more than 20 years. And I've been working with Sisgeo since 2015 as a sales engineer and an instructor. So over the years, I've specialized in the geotechnical instrumentation, and I've taught webinars, workshops, and some engineering schools. So today, our goal is simple. So to understand what the borehole extensometer are and how they work, to explore Sisgeo systems and technologies, and review some typical applications in the real world project. So this session will last about 45 minutes, and we'll finish with a question and answers. So if you have some question to address, if you have some, let's say, doubts or question for fields that I have not covered, so you have in your interface the link to address one question. Then at the end, I will take some time in order to review the most interesting questions, and I will take some time to reply to it. So let's get started. And just a small introduction, who is Sisgeo and what we do. So we are an Italian-based designer and manufacturer for geotechnical and structural monitoring instrumentation. I used to say that we are more than a supplier, so we are dealing with the whole world, but we provide instruments and also knowledge in order to choose the right system, and also to advise you and also your clients in order to have the right practice and the right way to use the instrumentation in order to give information and not only data. So the main sectors where we are acting are dams and tunnels and mines. So the other are, let's say, as important as dams and tunnels, but mainly, historically speaking, we have dealt with those markets. About us, just to note that this year in June, we became a new member of the Eddify technology family. So it is a Canadian group, Canadian-based group. So we joined Sensive and Sensor Networks within a new product line, which is called RMS, Remote Monitoring Solutions. It's a significant expansion for our range of products, and we give now the wireless connectivity solution made from Sensive to our customers together with the sensors of Sisgeo. About the different distribution that we can provide. So this is the RMS group. So a picture of RMS group. So we are based on many places, so mainly in Europe, as you can see. And if you zoom out for the full Eddify group in the world, then we are spread almost on all the continents. Now it's missing Colombia, I can see, so we have all the continent covered. Now let's enter into the definitions. Why definitions? Because if we are talking about extensometer, we have to understand what we are talking about in detail. So the extensometer, if you decompose the word etymologically, that means extenso, elongation, and metro, the measure. So this is a measuring instrument for quantifying the changes in length of a given line. So the physical quantities that we use here are the length, the distance, and relative distance or length change. So we can call it extension or shortening. So the unit that we commonly use are based in millimeters. So that can go up to centimeters if the displacement is big, but usually we are dealing with millimeters. The norm, which is covering this aspect of extensometer, mainly borehole extensometer, is this one, 18674-2. So I encourage you, I really support you to go to this document and then check what is stated, because you have plenty of information for the right way to choose and install the extensometer. Mainly, we can sum up the system types in two different categories. So the first one would be the surface extensometers. So they are measuring relative movement of visible structure at the surface. That means they are not always watertight because they are splash proof, okay, for against the rain, but they are not always watertight. But they need an effective mechanical protection because they are installed at the surface. So they are at the risk of shock or alterations. They can have all possible dimensions. So you can measure from micrometer to several meters. So it's not the subject of this presentation here. So you can understand this surface extensometer as crack meters or laser meters or wire meters. So just to separate the things, surface extensometers, now we are dealing with borehole extensometers. So the borehole extensometers measure the relative movements inside the ground. So it has to use watertight components because it's in the underground, so it's not against only splash proof. Here we are dealing with water under pressure. The extensometer is here linked to the ground because we are measuring component elements of the ground. Generally, they are long. They have a long dimension, so they are big dimensions, so more than 10 meters in general. Because the borehole, when you execute a borehole, it costs some money, it costs some budget. So we have to optimize the installation of such a system, and then to cover maximal lengths possible. So what is the purpose of an extensometer? So the general application in construction, so this is not the application in terms of objects, but what are the values or what are the phenomena that we are looking for. So the first one is deep ground movement. So only extensometer can help you to get some insight and data for deep ground movement. Then more specifically, you can measure the convergence. Convergence, mainly in excavation like tunnels. Then you can measure also the heave. So this is the vertical upward movement of a soil, or the settlement, the contrary, vertical downwards. More generally speaking, length changes. Anatomy of an extensometer. Important part, I would like that you understand exactly these principles, because if you understand this picture, then you understand the limitations and the points of attention when you are choosing a system and installing it. So the principle is to quantify the length change of a measuring line. So that means if you draw here a measuring line, then you have to choose 2 points apart, maybe split it by a joint or a ground layer or anything, but you choose 2 points. 1 point would be the distal anchor. So it's not exactly a fixed point, but it can be a fixed point. So this distal anchor is linked to a measuring rod. or a wire. So the movement of this point is transmitted completely through this measuring rod. Then what you measure here is not the full distance, but you measure only here the change, the movement, the local movement between the proximal anchor here and the rod, which is linked to the distal anchor. You measure this, you measure it through the measuring head or the measuring point, through a sensor or readout device. So this is the main principle that you have to keep in mind. Then you can see there are 4 main parts in an extensometer. So these 4 main parts are the measuring wire or the measuring rod. Each represents the measuring line. It can be rigid or flexible. The anchor, so you have per measuring line, you have 2 anchors, proximal, distal. So these anchors are fixed into the plan or the level to be followed. So one of the 2 anchors allow the measuring line to slide. So one is fixed and attached to the line. The other one has to welcome the line and to let it slip. It has to be mobile, very important. Then the head. So the head, it's a point, a structure, a marker fixed to an anchor, and it makes it possible to quantify and to measure the slipping of this measuring line. And at least the sensor or the readout device, it's a calibrated unit in order to measure this movement, slippage of the measuring line. So these 4 components are mandatory to build an extensometer. Each point has its specification and point of attention. But more specifically, I would like to focus a bit on the anchor. So you have mainly 3 types of anchor for an extensometer. The first one is self-buried. So the self-buried one is applied in non-cohesive material, non-cohesive soil. For example, sand. If you have sand, or if you are building an embankment, you are pouring some material on the ground, then typically we can call this anchor self-buried. Then you have the mechanical anchor, which is expanded, so self-expanded, or with some hydraulic or mechanical device. So this anchor will hook the ground at the position where you are installing it. And the last one is the grouted one. So the grouted one can be internally grouted or externally grouted. So if it's externally grouted, generally you fill the full borehole with the extensometer inside with a grout. Or if you have, like here, a packer, then this packer is filled with grout inside it. So the packer will expand and then link the anchor point here with the ground. So you can encounter this type of grouted packer for rocky soil, so rocks, which are completely jointed, so with full of cracks. So this is almost impossible to fill the hole with grout because you will lose the full material. The other application where you can find this packer is also very soft ground. If you have very soft ground like mud, then the only way is to have a grouted packer. In this way, this packer will connect hydraulically the mud with your system. So about the systems. So these systems will be split into 2 categories. So these 2 categories can be summed up between rod extensometers and tube extensometer. So the rod extensometer are divided into 2 parts: the head rod anchors, multi-point or single point, and chain of rod, and obviously multi-point. The tube extensometer is composed by tube, a guide tube, and inside this tube you will use an extensometer, so mobile probe extensometer. So the reading is made from the top with some systems, and the other one you are using local cumulative reading. I will explain afterwards. The other possibility is to use an in-place probe. So inside the tube extensometer, you will place some probes that will measure continuously the position of some targets. About the road extensometer, so you have the two types, head or chain type. Here on the picture, you can see the head type. So you have different sorts of tube extensometers, so road extensometer. So the first sort is the single rigid tube, what we call telltale extensometer or the D100. It's a very old system. So we have not invented anything, because the first time I discovered the use of this system was maybe in the 1950s or 60s. So it's a very old system. So the principle is an anchor. So let's say a grouted anchor or a buried anchor. So we call it settlement plate. So you install it inside a borehole or at the surface of a future embankment. Then you build a line composed by rigid steel screw tube in order to reach a surface point. So the surface or the summit of the embankment. The friction has to be avoided. So you remember the measuring line must slip freely on its length. So for that, we avoid the friction with the surrounding material with a corrugated deformable sheath. The reading then at the head is made either by optical topography, so you have here a survey point, or a special magnetic transducer, what we call DTM. So it's based on magnetic principle. So this DTM here can measure the relative movement between the soil, the surface, and this rod here. So this is a very simple system. It's modular on site because you can shorten or extend the system, and it's quite cheap in comparison to all other systems. The total accuracy that you can reach with the system can be between 5 and 10 millimeters in general, but it's more accurate if you are using a local sensor, something like 1-2 millimeter of accuracy. So to sum up, light price, conform with norm, proven efficiency because it's more than several decades, and easy readings. Now, when you are speaking about extensometer or thinking about extensometer, I think you are not thinking about extensometer every day, but when you are speaking about it, you imagine this kind of system, the MPBX. What does it mean? Multi-point borehole extensometer. So this is the, let's say, the most famous sort of extensometer that you can encounter. This MPBX is a collection, is a joint between 1 to 6 different monopoint extensometer, one rod extensometer. So the principle is to have 1 to 6 measuring line, so 1 to 6 anchors at different depths. And these bottom points can be grouted with a packer, you remember, or can be also so expanded with the packer, sorry, or grouted with simple rebar anchors like this. Then the anchor is linked to the surface, to the head, with means of a fiberglass rod or some stainless steel rods or invar rods. The friction is avoided here with a nylon deformable sheath. So it's a very small sheath, 10-12 millimeter of diameter, and this nylon sheath has the property to extend very strong. So you can extend up to 150% without a loss of properties. So you can have a big deformation on the length. So the reading at the head is made with either manually with a caliper or with an electric displacement transducer, what we call a DTE. So this DTE can give you an output in millivolts or 420 milliamps, or you can also have a vibrating wire signal. The most practical one is the fiberglass version. Why? Because the fiberglass version is pre-assembled in a factory. So you receive the fiberglass extensometer already rolled with the desired length. So you order with your different position, and then you just have to unroll it, then go and grout. It's modular in the stainless steel version because you can adapt and adjust every angle, but it's much longer to build. And let's say the most affordable one is the fiberglass version. The total accuracy is quite good. It depends on the quality of your anchoring, and it depends also on the, let's say, the straightfulness of the measuring line. So if your measuring line is not straight, not perfectly straight, then you will lose a bit of this accuracy. So the most important when you install this kind of system is to have a straight measuring rod. It's not that simple, really. But there are some tricks, but I cannot explain it here. I will tell you about the masterclass afterwards. So to sum up with the MPBX, so it's practical if we are talking about the fiberglass version, proven efficiency, of course, easy readings also, and conform with the norm. About a special system, so what we call chain extensometer. So if you assemble one rod extensometer one after the other with, let's say, one anchor per 2 unit segment, then you will have a chain of single extensometer. Here, the rod is a chain of tubes that are screwed together, so rigid stainless steel tubes of 1 or 2 or 3 meter length, and you can assemble them to some decameters because you can extend the distance between 2 anchors as you want. The friction here is also avoided by a deformable sheath, and the reading, so each segment has its own electric displacement transducer. So you have to run the cables outside the trench or the zone. It's very modular and affordable, and the total accuracy depends on the total length. So the shorter, the more, the better on the accuracy, let's say. So the schematic view is here. So this is a chain of different points that are linked together. So the head is linked to the distal anchor of the previous, etc., etc. And this has proven efficiency, and you will see an example afterwards. About the tube extensometer. So the tube extensometer, which we call the mobile extensometer, is composed by a central tube. So this central tube will welcome a manual probe afterwards. Then around this central tube, you have to position targets. These targets are magnetic rings. So you can see here the rings. So these rings have magnetic field inside. Then you position, so you build your system with inside the borehole always, or you can also continue the system inside an embankment. It's also feasible. You can also use not a simple tube, but an inclinometer tube. If you are using an inclinometer tube, it's interesting because you have 2D deformation, so X and Y, and you have also the axial deformation, so the extensometer. So you can follow in 3D the behavior of your ground here. So this anchor can be expanded here, like here, or grouted or inserted into an embankment. So this central tube is protected from the friction with means always of the same corrugated deformable sheath. And also, if you are using an inclinometer tube, then in this case, we can use telescopic sections. So these are special tubes which can accommodate some axial deformation. The reading will be made here at the head with means of the magnetic probe. So the magnetic probe is a reel with a band, and on this band you have a millimetric marking, and this millimetric marking can allow you to detect at which depth the detector, the probe, the end tip is encountering a magnetic field. So whenever you are encountering this position here with the magnet, then the buzzer will beep, and then you can just read out the depth of this first target. This is very simple. This is very modular. You can really arrange as you wish on the field, and it's quite cheap, this method. The total accuracy, let's say with this band, this method here is around 1 centimeter in general. Like price conform and also long-term efficiency. About the mobile extensometer, we can also speak about the dual point manual probe. In this case, we have a long probe, long like 150 centimeters. And the tube here is equipped with each meter, one magnetic anchor. So all the tube, if you have 30 meters, you have to build 29 rings with a space of 1 meter. Then this probe will detect the relative position between two anchors. So you measure here the reading number 1 between ring 1 and ring 2, and then you raise your probe to the next interval here between ring 2 and ring 3, and again here you measure the distance between the two rings. Then you make the full profile like the inclinometer, exactly the same, and then afterwards you come back on this side, and then you make the same reading and you compare the changes of relative distance between the rings. The good thing is that it's using an inclinometric tube, so you can make 3D. So it's 3D combinable. The accuracy of this system is 50 micrometers. So you can really measure very fine and low displacements and small displacements. So this probe is not a device, so it's not an easy device like the reel that we have seen before with the buzzer. Here you need an instruction to do that, but you can reach really a great accuracy with that. Then last, if you decide that you have to measure permanently the position of these rings, then you can use a fixed probe, so an in-place extensometer. So what we provide in Sisgeo is a DEX-S. So the DEX-S is an extensometer probe using the magnetic fields, and it contains also a biaxial inclinometer. So you have already your 3D monitoring inside your probe at specific positions. So the local reading is always made with one probe per magnet. So it's not made or difficult to have 1 meter steps with this system. So the minimal interdistance advised is 2 meters minimum between two adjacent magnets. It can also, in certain cases, we will see in the real cases, so the principle here is to be suspended. So you have a chain of different probe which is suspended from the top. But we have also a special version reserved for very skilled technician, let's say, with a bottom fixing. So why skilled technician? Because you have to take care you have to take care about the real depth where you will have your rings. So if you mistake the position of the rings between the rings and the probe, then you will not measure anything. So the adjustment is quite fine to be made. So it's not also a very easy system, but it's extremely accurate and efficient when you install it the proper way, because the accuracy that you can reach is 0.5 millimeter. It has proven efficiency and it's still conform to ISO. A small focus on the grout. Why? Because the grout is a very important point when you are speaking about extensometer. Why? Because you can purchase a good system, but if you miss this step of the grout, then you will not have the good link between the anchor and the monitored ground layer. So the composition of your grout mix must respect the resistance of the surrounding soil or rock. So this, you can find more information inside the norm or in my masterclass. So you can comment in the question masterclass in order to pre-register, pre-subscribe for the upcoming masterclass next year. So this grout allows the free deformation between different levels. So if you are dealing with extensions, then the grout is always soft enough if you use standard mixes. But if you are dealing with compressions, then you have to study the grouting mix much more in detail, because you have the risk that the deformation will not follow the ground. So you have to study this much more in detail in this case. About the data collation, if you are dealing with electrical sensors, it's different from mobile probes. So with electrical sensors, you can wire them to, for example, OmniLog, datalogger, or the mine readouts, or you can connect them to wireless systems like the Heave one, and display then the readings onto a web platform in order to interpret the measurement and make some alerts. If you are dealing with mobile probes, so for the magnetic detector reel, there isn't any registration. So you have to write down the measurements, but it's quite easy to do. If you are using, for example, the T-Rex extensometer, then you can combine with the brain reel and Bluetooth app, and also to calculate the cumulative deformation with means of Clion. So Clion is a software used also for inclinometer in Sisgeo. Now let's focus deeper on the typical applications for the extensometer. So where are the extensometer used? Mainly, not only, mainly in 4 different fields of application. One is tunnels. I would say the extensometer is friend of tunnels. So whenever you have to measure deep deformation, extensometer is always here. Then Earthworks, in order to accompany the phenomenon that will create some heave, some settlements, and also some lateral movements, slopes, also for the same reason, but here much more in an alerting way, an alerting operation. And last, retaining structures. So inside retaining structures, there are many, let's say, support elements, and these support elements can be also accompanied by readings of extensometers. Some application overview. So the settlements of soil embankment, monitoring in dikes and earth dams, so the lateral expansion of the dam base or settlements inside the earth dam, landslide and retaining wall, so here to monitor the lateral movements, instability of some cliffs or mines, deep excavation, it's a retaining wall, for example, convergence of galleries and tunnels, extrusion of the tunnel face, and of course accompany the tunnel, what we call mine by monitoring. So we pre-install the extensometer. Just afterwards, we can see that. So the typical application tunnel. Then you can, for example, measure the absolute convergence and the damage zone, the expansion of the damage zone. So whenever you are building a tunnel, especially in rocks, then you will create a cavity. Tricky, yeah, but basically tunnel is a cavity. Whenever you are digging this cavity, you will release the earth pressure there. So the material will begin to contract, and so basically the hole is going to close. So in order to measure this effect, what we call the convergence, we commonly use optical targets. So the principle is to measure, so to draw a polygon, and then to measure the distance between the points. And the distance change will give some information about the form change. So if the channel is closing in a, let's say, symmetric way or asymmetric way, for example. But if you want to measure exactly the total convergence, the absolute convergence, the best is to use an extensometer, because we use the extensometer to reach a zone which is not affected by the deformation, so deep enough. And from this deepest point, we can also build other anchors, so multi-point borehole extensometer, in order to evaluate the extension of this excavation damage zone. So inside this excavation damage zone, you will have an influence of the tunnel, and the distance, so the thickness of this ADZ is quite important to see if your support, if your build, if your design is stiff enough. So the most convenient product for this purpose is for us the Maxid, because the Maxid is a miniaturized extensometer. So pre-equipped, you have all the anchors, you just have to unroll and install. No stick up at the borehole wall, so it doesn't take any space in the tunnel. Also small diameter, so you can build it into the very small diameter. It's an economical argument. And the cable going out is reinforced. We have also a digital version to make more efficient the cable wiring. Here an example in South America, where you can see here a cavity. So it's a bigger than a standard tunnel. It's a cavity for building a turbine, for example. And here, for example, you can see some 4 points Maxid extensometers. If we are looking at the data, here you can see a very typical convergence, so absolute convergence curve. It means the deformation goes very quick at the beginning and then tends to stabilize in the time. This is the most important data that we are looking for when building a tunnel, because when the deformation is very strong, you cannot build the final concrete element, because you will break it. So you have to make a soft support in order to accommodate this first stage here. So this red curve is given by the deepest anchor. So I told you that this deepest anchor was in a stable zone, but this anchor is linked to the head with a rod, you remember? So each anchor has its own rod. So the head is moving because the cavity is converging. So that means that the major signal, the major deformation is obtained between the standard, the stable point, and here the head. And this is why you have this type of curves with decreasing signals as long as you are considering the shortest anchors. So the longest anchor will give the greatest signal, etc., etc. Then about the mine-by monitoring. So the principle here is to pre-install some at some specific points extensometers, and then whenever you are building the tunnel, you can see online the behavior of the ground. Here, the head position can be controlled with topography. In this case, MPBX or T-Rex indexes are convenient, so they detect the effect on geological layers. And here you can also combine with the T-Rex indexes with inclinometer. So it's a clear added value in order to have only one borehole with all the information. And the advantage also is that the electrical transducer or the probe can be reused. So here you can save some budget on it. Some examples here in Thailand and in France, where we were dealing to monitor some subway project. So the extensometer are pre-equipped inside the boreholes. A special case here in tunnels is the extrusion monitoring. So the extrusion monitoring, what is it? The extrusion is an effect when you are digging a shaft or when you are digging a tunnel. So the surface that is braked and excavated will tend to have axial convergence. So you will have here a deformation because you are creating a cavity, and naturally the pressure is released, so you will have a deformation. And this data gives some insight on the upcoming geology and upcoming quality of the soil. Then in advance, you can forecast the influence that your tunnel will have on the surface, or the quantity of support, anchors, etc., that you will have to employ. So here, the heave of the sole at the bottom of the shaft can be measured also with a fixed installed extensometer, in-place extensometer, with means of a bottom anchor. Here, you cannot suspend the probe because you are excavating. So the advantage of this tube extensometer here is that we are using plastic tubes that can be excavated, so destroyed. So in advance, you can destroy and then measure. Here, you will keep alive the system because it's linked to the bottom anchor. For example, here in France, we have installed two bottom anchors with a DEX-S system. And you can see here the detection of the influence of digging a shaft on the underground. So here you can see up to 12 millimeter of heave in advance during the excavation. For the earthworks, so here we measure generally the settlement, vertical settlement, or the lateral extension with a chain extensometer. So here what we use generally is the tail, the simple rod extensometer with steel tubes, or the BRS. So this is the one with the magnetic probe with the buzzer. It needs to, in order to measure settlements, it needs very rigid measuring rods. So in order to measure the compression, MPBX, so the multi-point borehole extensometer with fiberglass, is not the right instrument. Why? Because the nylon sheath is not able to accommodate strong deformation in compression. And this is why we advise the corrugated sheath, as you can see here. So this sheath is able to compress, but not the nylon tube from the MPBX. Here you can see some examples of earthworks. Then slopes and retaining wall. So the principle here of extensometer is to detect the crack activations and the mechanisms of topping. We can perform the boreholes, so mainly horizontally or sub-horizontally, through the retaining wall or the retaining structures, or directly in the rock. So in this case, MPBX is the best system. If you want to prevent some shearing effect that can affect the reading, then you can use steel rods instead of fiberglass rods. This extensometer here in the retaining wall can also help to understand how does the tieback deforms. Because the tieback, generally, you are measuring only the resulting force at the head with a load cell, for example. But if you want to measure the complete distance change, then an extensometer can help for that. Here's some examples of installations and conditions where you can install this MPBX. So generally speaking, you have to protect them and to include them inside the wall, because you have plenty of cranes and struts and engines, and here you have a lot of rocks that can fall on it, so you have to protect your device. It's very important. So thank you for having followed this this webinar. Thank you for your attention. Now we can open the floor to your question if you have some. So just to wrap up, we can summarize the key points for today's session. Borehole extensometer are essential tools for monitoring axial movement in the ground. They had to detect the convergence, the settlements, and other critical displacements in tunnels, earthworks, and slopes. Sisgeo provides a complete range of extensometer systems, so rod extensometer, chain, and tube types, each designed for a specific application and accuracy requirements. So these instruments are vital for safety and risk management, optimizing construction processes. So if you would like to learn more, you can visit our website and also subscribe to our upcoming next year masterclass to have much more detail on it. So now I can welcome your question. Okay, so just let me some moment to read it. The best question, because I'm sorry, I don't have the time to reply to it, but it's the most interesting one. It's is the grout to be adapted to the ground? Is there a recommendation for water cement ratio and with bentonite? Yes, the reply is yes, there are some recommendations, and please follow them. It's very important. So inside our manual, we have made a caption of the normative requirements. So these are very basic but accurate recommendation. So you have to use light composition for soft ground, and a quite stiffer composition for the rocky environment. But again, you can find this information in our manual. What could be the maximum length of a telltale that is buried into an embankment? Let's say there is no limit. You can make an infinite line, but to be practical, when you are building in an embankment or a big dam like here on the picture, if you are building a big dam, you have to follow the verticality of your line. So imagine you have the bottom ground, then you place the plate on it, and then you are just screwing the next rod. It's straight, no problem. Then you cover it with a corrugated sheet, okay? Then the engine will come to pour the material and then to compact it. It can happen very easily that you have a shock, or maybe the compression will bend a bit the line. This has to be avoided, because if your line is not straight, you will lose information. You will not be able to let it slip. So the longer it's the worse. So it's difficult to maintain the verticality for a line which is 40 meters long, of course. So the majority of the clients which are who are ordering this kind of system are mainly with 4 up to 8 meters of length. So this is the good practice, let's say. What are the advantages of invar rods compared to flexible fiberglass? So advantage and disadvantages. Disadvantages is clearly the price. It's very expensive compared to fiberglass, and also the time needed for the installation. Just compare. If you have a fiberglass extensometer, so it's pre-equipped. So you order to me, for example, you say, Julien, I want an extensometer with 4 anchors at 2, 5, 10, 20 meters. Then I pass it to the production department and they build exactly these distances. So the extensometer comes exactly as you wished. You just unroll it and then you install it into the borehole and you grout. So it's not very long. If you compare with the invar or the stainless steel, then you will get everything like an IKEA kit, and then you will have to build each line one after the other and to assemble it onto the extensometer head. So it takes a long time. And then you have to be very cautious at every stage of the mounting, because if you miss something, then you will not be able to install your displacement transducer, for example. Good question, by the way. So the ISO norm that controls the installation, I have quoted it. So it's 18674. So you have plenty of sub-chapter inside this norm. So the -2 is the extensometer, the -3 is the inclinometer, the -4 is the piezometer, and then you have 5, 4, 6, 7, 8, and 9, which are still under process of validation, but coming for strain gauge, load cells, etc., etc. Does the grout allow the magnetic ring to move vertically? It's a good question, because the answer is not yes or no. Let's say the magnetic ring has to be installed according to your material, to your geology. So if you have, let's say, a very soft ground, then maybe the magnetic ring with the spring legs will be okay, but maybe not. So we have a version with 6 spring legs, so 3 at the top and 3 at the bottom. And in this way, you can have more hook, more grip into your soil. If you have a very hard ground, then the hook will not act on the ground. It will not hook the ground. So in this case, you need to make grout. So the resistance in compression of this grout must match with the environment. So if you have many different layers, for example, you have a soft ground at the top and then a hard ground at the bottom, the better is to make the grout according to the softer layer. But if the difference is too wide between the two, if you imagine you have mud at the surface and you have granite at the bottom, in this case, it's better to make 2 grouts, 2 different grouts. So the harder one, then you wait 1 day and then you make a softer one. Then it can work. Then some people want to have a masterclass. It is a good idea between us. What is the diameter of the IPI extensometer tube? So the tube itself is an inclinometer tube, so it's 76 millimeter diameter outside, but the ring is bigger. So the ring is 90 millimeter. So the best diameter to perform a borehole is for us 120, 125 millimeter available. So if you have a protection casing, you have to manage this, the internal diameter of the protection casing, 120 millimeter, because you have to insert also the grouting line. So the grouting line plus the ring, I think this space is good enough. What are the anchors of MPBX suitable for each type of soil and rock? So the MPBX basically is always supplied by default with the rebars. So the rebars are 50 centimeters long rebars, so steel, galvanized steel construction rebar, which has a lot of friction. Then you include it into the borehole, and then you have to link it to the ground with means of a grout mix. So the grout mix, basically, you remember, it's a bentonite. I didn't say it, but it's bentonite, water, and cement, which are mixed in good proportion according to your geology and the soil resistance. So this is the standard, very standard one. So this one has to be installed in, can be installed in almost all the soil, as long as the structure is plain. So if you have some cracks, for example, I would avoid that, because if you intend to pour and to fill the borehole full of cracks with a grout, then the full grout quantity will go into the cracks, and then you will not be able to fill in, and then you will not be able to link the anchor to the ground. So in this case, we advise the packer system. So instead of having an anchor, then you will screw on it a packer, and this packer has a special tube in order to fill the cavity of the packer. So the packer is surrounded with a geotextile, and this geotextile is like a pillow, and then you fill this pillow with grout, and the grout is not hermetically trapped inside the pillow, because this is a geotextile. So the water and the fine elements of cements will link the interior with the surrounding soil. So it works good because it will make a really good link with the surrounding soil. And as I said, this packer can be also installed in very, very soft ground or mud, because in this case, this packer will expand also the mud and make this kind of blowed packer, so bigger volume. So in this case, yes, it's a good choice to do the packer. So what your question was each type of soil and rock, I would say 99% of the case rebars, then in special cases the packers. Just a small remark: if you install an extensometer, for example, in the tunnel upwards, it's a tricky installation, because in this way the gravity will tend to make the rods go in spiral, because it will not stay rigid. So in this case, it could be advised to use packer in order to maintain the position of the packer, and in order to push the packer in the good way. So the fiberglass is maybe too weak, so maybe you have to use stainless steel rods. But just to understand, stainless steel rods and packer is a very heavy system. So in this case, you have to use machines. So only with the hand, with 2 workers, it would be too hard. So in this case, you have really to design upfront your extensometer. What can happen if we don't use casing for borehole and the borehole is too big? The sphagnum magnet did not hold on the borehole wall. Are the readings still okay? Yes or no? Yes or no? So that means generally the ring, as I said, is 90 millimeter of diameter. So the spring legs are made to accommodate up to, if I remember, 300. So 300 millimeters. So I cannot imagine that you perform a borehole and then you have a big cavern inside it. So this case should not happen. It should not happen. But if it happens, and if you discover it, because what will happen if we don't use, it means that if you discover that for any reason your borehole is too big or any dimension which is not suitable with the spider rings, then you can also decide to make a grout. And in this case, the surrounding soil will be linked to your magnet ring. And since you have a corrugated sheet, then the deformation will be possible, but you have to study your mix in accordance to your expectations. If you expect some settlements, then you have to accommodate the mix with these properties of soils. If you are expecting some extension, then it's less problematic, let's say, a bit less. But the important is to respect the diameter which is advised. Thank you to everyone for your questions. It was interesting. Thank you for attending this webinar. Please feel free to reach us onto our email address. You can visit our website where you will find plenty of information, manual, FAQ, also the big data sheet that we provide, or the best data sheet of the market, for sure, because I participated to write them, so it's good. The videos, like the video we are now registering, and very interesting application notes. And go to the social networks and click on like Sisgeo. Thank you so much for having followed, and see you next time. Bye-bye.